and also some stimulation for the next presentation, which are going to be a little bit more, I would say, gutsy. Okay, fundamentals of rural roads. Next slide. I can't run this presentation, so Kim's got to do it. Can you do the next slide,
There we
Kim?
go.
All right. So why do we have roads in the first place? Well, to get access to our properties and for our uses, whatever they are, residential, forestry related, whatever they are, and then to provide emergency access and escape routes. And that has become an increasingly important topic for us who live in rural areas. And we do a lot of work with the El Dorado and Georgetown RCDs on improving emergency access through vegetation clearing. Um, I can't emphasize the importance of this because, many of the tragedies that we've had with wildfires in California are due to lack of sufficient emergency access. Next slide. So we have different types of roads. We have permanent all-season use roads. Typically, these are county roads. We have permanent seasonal use roads. These are often roads that are used for, uh, resource management, timber harvesting, or whatever. We have temporary roads and trails that are installed to facilitate a particular use. And then we have what are called legacy roads. And these may be in use or not in use. And these are the roads that are on the landscape that we had nothing to do with. They were there when we got the property, and they may or may not be in good shape, and they may or may not serve access for our purposes. In some cases, they're totally superfluous. Next slide.
Richard, I'm going to pause just a moment. I want to make sure everybody can see the screen. I have a couple participants that are saying they're not being able to see the
Oh,
screen.
my goodness.
If you could just pop in the chat box for me, that would be great. Yeah, I'm getting thumbs up. People are seeing it. Gray, I'm not sure what's going on with your computer. Thank you.
Typically, that's an internet problem.
Mm, all right. The next slide is up, Richard.
Okay, yeah, it says some people are not having luck with this.
Yeah.
Oh, wait, that's typical. It seems to happen a lot, and I'm not sure it's because people sometimes use hotspots for their access as opposed to wired internet.
Mm.
Okay, so road standards and the design should suit the uses, and this particular road that we're looking at here is in San Mateo County. So this is an all-season gravel road with slope protection. That's what that wall is for, and a armored drainage ditch. Just this last weekend, I went over on Highway 92. I don't know when the last time you went over Highway 92 to Half Moon Bay was, but they've done incredible work on slope protection over there in terms of installing walls. It's pretty crazy. Next slide. So the design criteria that typically go into planning a road, the width, the gradient, um, the curvature, the drainage, the surfacing, and those are determined by the vehicles and the traffic levels, right? So critical vehicles. So for example, if you're going to be having a road where there's going to be access needed for low bed trucks, it can only be at a certain grade or they can't maneuver. And then I don't know if you've been on roads where somebody with a big low bed truck is trying to come around a curve that's like a hairpin curve and they come into your lane. So, those are the issues that we need to address. And the critical vehicle is what determines that, and the amount of traffic. And then the seasonality of use. I mean, is it going to be used all year round or is it going to just be used during the dry season? And of course, environmental constraints, and those are numerous, not just related to water quality, but related to wildlife and other issues that, you know, impact the design of a road. Next slide. Unfortunately, a lot of the roads that we have are inherited. They weren't designed with current uses in mind, and they weren't necessarily designed with design criteria in mind. They were just sort of stuck on the landscape. And this particular road you're looking at here is a incised road. There's no drainage on this road. It just has to go down the middle of the road because it can't go off the sides and there's no ditches. Next slide. So landowners are often faced with chronic problems caused by poor choices made in the past. And typically, the majority of these problems are related to drainage, the lack of drainage. In other words, a road is put in and there's no provisions for getting water off the road without causing erosion or sedimentation in streams. Next slide. Inadequate stream crossings are a common problem. I mean, it's interesting that like the forest practice rules have been changed to require that installed stream crossings can pass 100-year flow plus entrained sediment and debris. Many of the culverts and crossings we have, even the bridges we have on the landscape, are undersized and they can't handle peak flows. When we have a peak flow, they just blow out and they're subject to failure or chronic plugging. Next slide. Many of you probably already know about these issues, so I'm not telling you anything new. You're probably out there during a storm trying to clear your culverts because they're undersized. Tension cracks in the road surface here caused by interception of a spring and the road base saturation, or slope failure caused by stream undercutting on the outside of a meander bend. Poorly located roads. They may be in unstable locations. Next slide. There might be chronic impacts on streams. What you're seeing on the left here is a sediment plume that's caused by the discharge of road sediment from a stream into a stream via the inboard ditch. The ditch is basically a conveyor belt for sediment and it's just delivering it directly into the stream. And so you see this sediment plume coming down the stream. Roads are commonly built right upstream valleys in the old days, often following railroad grades. And because of that, there's often chronic sediment inputs into streams. Next slide. So the wish list for a good road. Designed, built, and maintained to withstand stressing weather events. And that's really one of the key things right here is that you want your road to be able to weather a severe event, a high intensity rainfall event, or a rain on snow event. You don't want it to be basically get blown out during those events. You want to have just enough road for the uses, just like, Three Bears. You want both length and width. They're just enough for the uses. You don't want more road than you need. You want it located on stable terrain or away from streams. And sometimes people think, oh, well, that means put it on the ridgetop. Well, it's very difficult to drain roads that are on a ridgetop. So preferably you put it on the contour so you can facilitate drainage. And you want hydrologic invisibility. And that means that runoff from the road is disconnected from watercourses. And this can be achieved in a variety of ways, but often what we see is that drainage ditches just deliver sediment directly into streams at crossings. Next slide. So alternatives that we have inslope roads with ditches that may convey runoff and sediment directly to streams. Doesn't necessarily have to happen that way, but it commonly does. And these, typically is your county roads, right? Then you have outslope roads that disperse runoff and road surface erosion onto adjacent slopes. So this is kind of, over the last maybe, I don't know, 20 years, 30 years, the concept of the outslope road as an alternative to an inslope road has gotten a lot of traction, but there's only certain places that you can use these kind of roads. Next slide. So inslope with ditches, they may drain well, but they may be directly connected to the streams. If you can disconnect them from the streams, then they work fine. they require a high level of maintenance. You got to clear the ditches. You got to clear the ditch relief culverts. And they're typically, again, county roads, permanent year-round use roads. Outslope roads, with or without rolling dips, are good because they disperse road drainage and minimize sediment delivery. They're not suitable everywhere. I mean, just think about it. You've got a nice outslope road in an area which is susceptible to black ice. It's no fun. So you have to be careful about, the climatic and the geologic conditions that you put these roads in. So they're typically done, for seasonal, temporary, secondary, and some permanent roads. Sierra Pacific Industries, for example, has really done a lot in this area of installing outslope roads with rolling dips to try to avoid all the maintenance that's required for insloped roads. Next slide. So road surfacing, if you're only using a road during the dry season, you may not require any surfacing. Uh, or the surfacing may be only required at places like stream crossings and wet spots. What you're seeing on the left here is an outsloped road, basically in a wetland, and it works perfectly fine. What you're seeing on the right is a surfaced area at a stream crossing. And the rest of the road was naturally surfaced, but in this area, they armored it with gravel. Next slide. So stream crossing alternatives, if you can get away with it, low water forwards are a reasonable and cost-effective alternative to culverts and fills. Just recognize that when you put a culvert in the ground and a fill, you're committing yourself to long-term maintenance. So if you get away with low water forwards on intermittent and even on some perennial streams, then you're going to save yourself a lot of maintenance headaches in the future. Next slide. Culverts and bridges, if we have fish-bearing streams, that's a special issue in terms of, how you deal with culverts and bridges and facilitating passage. All cases, and I don't know how the counties are dealing with, whether they're requiring the passage of 100-year flows, but I know the Forest Service and CAL FIRE for forest practice rules require the crossings accommodate 100-year flows plus entrained debris and sediment. Next slide. So fish-bearing streams require special designs. In this case, on the left, they've got a gravel bottom in a arch culvert that allows fish to pass and actually even to spawn. And on the right, you have another that's a crossing where basically you're facilitating fish getting from one part of the stream to the other with a kind of with a leap, essentially. Next slide. So more information, I think that, I guess, Kim, you're going to provide these PDFs to people if they want them, right?
Yes, we will.
Okay, so you just can't beat the UCA&R website for information on these topics. And I mean, way back when we did this 3-part webinar series on rural roads, and there's just a ton of information there. Just, if you have trouble sleeping, it's a good place to go just before bedtime. Uh, and the presentations are available as videos that are posted on YouTube and as PDFs, so you can download them and look at them at your leisure, or you can actually see them online. So that's all I have. Anybody have any questions?
Thanks, Richard. Yeah, we'll pause here for just a moment. And if anybody has any questions for Richard, please go ahead and put that in the chat box.
Wow, I covered it in my time allotment too. How about that, huh?
Well done. All right. Well, while we pause here, Susie, you are up next. If you'd like to start your presentation slide and introduce yourself.
Okay, I hope that works. You should be seeing my screen.
Yes.
Okay, well, I'm Susie Kocher. I'm a cooperative extension forester for the Central Sierra Nevada. And I've been with Extension for a number of years, including quite a few working with Richard and working on some of those same road projects with him. So I'm going to go ahead and bounce off of what he said and talk a little bit about how to assess your road if you are a manager of a rural road. Okay. So ideally, right? So Richard gave you some ideas of some of the good parts of roads, some issues with roads. If you are managing a road on, say, your own private property, one basic step is to actually do an assessment of your road and identify the problems, and then try and identify what solutions or strategies may be available to improve the road that you already have. So there are a lot of different methodologies to do roads assessments. There are some that are very quantitative. There are consultants that you can hire to assess your roads for you, some of them with a lot of geology or geomorphology expertise involved. And doing that kind of high level assessment could then help you be in position to ask for grant funding for doing work to address your roads. But to know what to do, you have to know what problems you actually have and where they are. And so we came up with a basic methodology, Richard did, that's a roads assessment checklist that's usable by a private landowner, where a lot of these issues are described, and then it's up to you to identify that you have them or you don't, and ideally put them on a map so that you could approach some kind of agency or collaborator that might be able to help you figure out what to do with your road. And so here's a random stretch of road with quite a few issues. Sloughing cut banks, degrading fill slopes, and all of that. So imagine that you are walking down your roads and you are identifying what kind of issues you have. So you want to be able to record specifics about your road, the width, which would include the running surface. So not just the shoulders or anything like that, but how much is available for transportation, what the grades are, what is the percent slope from the steepest to the gentlest. If some of you have been in our stewardship workshop class, we have an actual orientation to the California Cooperative Forest Management Plan. And this is a piece of data that's asked, like, what is the range of slopes of the roads that you have? What are the surfaces that you have? And then identify what kind of drainage along your road, whether it's insloped with a ditch, outsloped, or you can't tell, or, you might not know. So while you're there, and this is just a map to help us think, this was a project at our Hopland Research and Extension Center. There was an assessment of the roads issues, and it was mapped. So you can see maybe by my arrow, there's a spot 71.1, which has some kind of issue. So I would encourage you to get a map of your property, walk your roads, and identify where you see issues and put them on a map so that you can talk with professionals to kind of give them an idea of what kind of issues you're facing. So these are the ones that we are going to describe, and Richard did describe a lot of these. We have cut bank sloughing, fill slope erosion, rutting, potholes, wet spots, gully erosion, eroding ditches, and other problems. So I just thought I would give you some pictures of what these things look like and some vocabulary for you to be able to use our checklist and identify what's happening, right? So this is the cut bank. That's the upslope part of the road. In order to put this road in, you have to picture that there used to be a slope right here, and a road was cut into the landscape. And so usually there's a cut bank here, and that sediment can slough off or fail. And then see how this used to be a slope. There often is, unless you cut in an entire road, you might only cut in half of the sides, and then all the stuff you cut out, you put in as your fill slope. So the stuff below is your fill slope, and there can be failures there. So that might even be the same picture that Richard had. Yeah, this one's pretty visually obvious. Plugged culverts. You can see this. This happened not that far from my neighborhood in 2023, in that big water year after the huge snow here in South Lake Tahoe, where the culvert plugged and there was too much water, so it just went right around it and abandoned the culvert. They've done a lot of work on that house, which is about half a mile from me, and just taken out the culverts altogether and restored the stream banks. Here is what a gully looks like. This is also at the Hopland Research Station. So you can see how something is happening here causing a gully. What's actually happening here is the road is up here and there's drainage off the road, which is causing the gully. And although people often think that the solution is to plug up the gully, really the solution is to move the drainage. So where it falls off some other way and doesn't have the ability to cut that gully. That's a big gully. You might have smaller rills, which are also sediment being taken away by water, but a much smaller size. Another issue that you often find is that if you have a road with an inboard ditch, sometimes you are allowing the water to escape from your ditch by going under the road. So this one is properly done with the slope that is correct for not causing too much erosion. And then there's an outlet protection with riprap for this water that's coming out. Here's one where it's too flat, and so the water is coming out on this unprotected slope, which can cause erosion. And so one of the things that can be done there is to have a pipe put in to bring the water down closer onto riprap. So this slope of these cross drains can be one of the issues wrong with your road. Okay, Richard talked about crossings and all these types. So you would want to assess what kind of crossings do you have on your road. Fords are not that common. Culverts are generally where it's at. Bridges are usually the least problematic, but the most expensive. Is the actual crossing in good condition? And how does the fill slope around it look? And so there are some of these issues that we're going to look at here. It could be undersized, it could be not aligned, could not be at the slope of the stream. It could be causing erosion below the crossing or above it. It could be at the wrong angle so that sediment fills up above the culvert. It could be prone to plugging or have the ability, because of how it's shaped, of diverting the stream entirely around your culvert. So here's an example. This could be your road, and because of the angle of the crossing, there's a lot of potential for this water just to continue down the road. A better would hit it at a 90-degree angle. You could have drains above, and then you have armoring here so that it's less likely that the stream would escape and travel down the road. Right, so these are just like fundamental things that hopefully as you walk down the road, you would notice as an issue with your crossings. But if it seems complex, also it's possible that you could get a professional to help you. So, okay. Here's that culvert that Richard was showing us. Sometimes the culvert are put in too deep, and so there's not enough room for all the water to go through, and instead the water goes over the road. Or it could be too high, and it's causing erosion underneath as you put the culvert in, right? So what you really want to do is put the culvert in at exactly the same grade as the stream or the channel below. So that's the best type of placement. But you could have this issue, and when you look upstream, you kind of see that sediment is deposed, and if you look downstream, you see a lot of erosion. Okay. Diversion potential. So here's that example. I showed you where it actually happened in a photo, but here it is conceptually, right? So here is a stream and something happens to plug the culvert, and there's no specific way for this water to escape. So it fills up a pond, it goes onto the road, and then the road is the lowest grade, and it follows the road and wipes out the road. So that is an installation that does not give your culvert a chance to recover. This is called a critical dip. So if in case this culvert plugs up, the water builds up, it gets up onto the road, and it's already got a little dip here that's armored, which is going to tell it the easiest path of least resistance is to go right back over the culvert and back into the stream. So that's a way to reduce the risk that your stream will be diverted down the road and take out the road or take out the culvert. So that's one strategy. Okay. Richard talked about road upgrading. So I just have some pictures of those to actually solve the problem. It would require, in some cases, to seat your cross drains. If over here what you have is a ditch and the drain wasn't working correctly, it was too much at an angle, or it was too tilted up. And so a replacement of these culverts can help to make sure that that is not causing erosion out the side of the pipe. And then some armoring often is done to make sure that that drainage is working properly. Here's a picture of fill slope stabilization. So Richard showed you some cracking happening because of water, or maybe this actually failed. And so a project that actually goes in and stabilizes this, probably with rock underneath and some chips to keep any erosion from happening, is often one of the treatments for this type of site. Here, if you identified that you had some cut slopes that were sloughing, you can have rock put in. Where I am in the Tahoe Basin, I see a lot of rock-filled gabion baskets. So these would be baskets of rock, and then soil falls in, and there's some plants coming out. There's still a lot of wire mesh all through the landscape, but it does kind of get more vegetated over time. And there's some bioengineering solutions where vegetation is considered part of this treatment rather than just rock. But I have to say, this is probably the most common, just riprap to hold in that soil. Another strategy, Richard talked about how ditches can convey sediment right to streams, is to armor the ditches so that any water conveying sediment has a chance to settle out, slow down, and not get to the streams as quickly. And also those rocks obviously cover up the sediment, so they're not a source anymore. So this is also a quite common solution. And here's Richard's picture here. This is a difficult kind of slope, and this is a rolling dip. So the idea is that this dip drains off to the side, and it's rolling because that means you don't build it so deep that you can't just drive over it, right? If this were a huge dip, this would be called a tank trap, and it would impede your actual use of the road. But here is a dip that's supposed to help drain a ditch off to the side, and you can still drive on it, but just a little bit with a hilly, fun atmosphere. And then here's road recontouring. So in this area, it looks like I wouldn't worry so much about black ice or snow. And so to fix the drainage issues, there's some recontouring going on to make this a outsloped road. And then the water goes off on the side without ditches or culverts oftentimes required. And here's what it looks like if you surfaced it. So surfacing can be one of the strategies to keep whatever sediment might want to make its way off this road as well. Paving and chip sealing. So these things are expensive. All these things are kind of expensive, but it is a long-term solution. Obviously, paving requires maintenance over time, but where I live on the Dorado National Forest has like the most paved roads I've seen on any national forest. Some engineer, I don't know, in the 60s or 70s must have really said, we need to do this for the long term. So a lot of Forest Service roads you'll see are gravel, and so there's more maintenance. And I think someone in the chat talked about washboarding, but that's really not an issue with pavement so much, although of course there can be issues. Okay, armoring the fill slope and the culvert outlets. I kind of showed that a little bit, but here's an area where there was erosion happening. And so this fill slope has been armored. There's some chip to keep down sediment. And then the culvert outlet itself is armored so that it's not carrying any sediment away. It's slowing down, dispersing its energy. By the time it gets down here, it's probably not carrying sediment. So here what we're looking at is revegetating cut and fill slopes. This can be done as well. Obviously, it's a long-term project, and it's not necessarily needed. You could do it with rock, but some people are going to want to do that depending on the circumstance. And then the idea of disconnecting ditches from streams. So this was a project that Richard and I were involved in at our Hopland Research Station. And this is a map of before their project, the watershed area that drained directly into a ditch that drained directly into a stream. So you could map out that area and look at the inboard ditches and figure out how much of those areas went right into streams. So one of the strategies is to disconnect these watershed areas from streams through outsloping or those cross drains or however you're doing it. And so you would map it beforehand, and then let's see, after your project, at least for a while, you have managed to reduce that sediment area that goes right into a ditch. I mean, you can't do it everywhere. You might need inboard ditch right here, but then over in another area, you have the ability for that water to drain off to the side, and you're not getting it to the stream. So this was the outcome of a pretty extensive and somewhat expensive road upgrading project for our research station. And I just wanted to quickly describe road decommissioning. So this is eliminating a road. You may not need a road. It may be a chronic source of sediment or fail. It's in an unstable area. Maybe what you'd like to do is get rid of it altogether. And that can be done. It is an expensive proposition in general. This is one in, I believe, Redwood National Park. So you have to picture that there was a road here. There was a culvert. There was sediment perched on top of it to allow the road. And they brought heavy equipment in. They pulled out all the sediment and they removed the culvert. So it is something that can be done, but as you can imagine, it does require heavy equipment, and that all gets pretty expensive. So there are less expensive ways of doing it, like not completely finishing the surface, maybe just pulling the culvert. And then maybe if you needed the road later, you could replace the culvert. Here's the perched fill. Underneath is the culvert, and the surface of the road went that way. Here's a picture with Richard. We did a workshop up here in South Lake Tahoe in 2013. That's already a really long time ago. But post Angora fire, the Forest Service decided that this road was no longer needed. And so they did what we just showed you, took out the culvert, removed the perched fill, and returned it to a natural stream bed. I mean, natural sort of, like you can sort of see. Here's a project workshop we did with California State Parks. This is Ward Creek State Park in Tahoe City at that workshop. And this was the road. And they fluffed it all up and left it all in this kind of fluffy condition. That's what they called it. You couldn't drive on it anymore. And they were hoping over time it would revegetate. There were some other areas where they actually converted roads to trails. Here's what the road looked like. It was a big issue. They wanted to change it, to put it to bed. And so they, not shorten, but reduce the width and put material there and encourage people to ride their mountain bikes on it. So that is another strategy. Here's another strategy with state parks, just some rocks, keeping people from driving on the road with the hope that this road will recover. Homewood Mountain Ski Resort's actually done a whole lot of work using chip and trying to restore the soil of the area. So this was a road. They used all their chip that they got from, excess tree biomass and dug it in and replanted it. You can still sort of see, but, it doesn't look like a road. And then this was an entire meadow that they had a big road through, and they did that same treatment there. So those are the ways to think about upgrading or decommissioning roads, but I couldn't not say that road maintenance is also an important tool. So if you maintain your road, even if it's a problematic road, you could prevent it from failing by being there at the right time. So we often see our public works departments doing this. They go out and inspect all the culverts in my town before the winter season. They make sure the ditches and culverts are free of debris. And then it's more likely in an extreme rain event that those things will pass instead of wiping out your culvert and affecting your road, right? If you regrade and shape it periodically, maintain your surfacing, and close it during wet conditions, then you will have less problems in the long run. We would encourage you, if you're out on your property, to put a shovel in. And so if it's raining, you can get out there and redirect the flows and save your culverts from failing, even if they are undersized. And in general, to keep maintenance records. If this is happening and you're out there, you will notice what the problem culverts are. And it will help you make your decisions about where do I need to really spend the money to upgrade if I realize that I'm constantly going back to this one culvert because it's the problem.
Hey, can I editorialize for a minute here?
Go for it. I was
I think,
done.
yeah, I think a lot of landowners who are sort of informed about this, what they do is they flag their problem culverts, so they know that when things are getting ruckus out there, they know where to go. So it's just a lot of the counties, what they'll do is they'll put some kind of a some kind of a signal, like a stake or something that tells them this is a problem culvert. And that's really a good practice. Sorry.
No, that was perfect. I was done and happy to have you say that.
Thanks, Susie. Thanks, Richard. Before we go on to Mark, there are a couple of questions that were put in during Richard and Susie's talk. So the first one started from Jim about how to handle washboarding.
I'm happy to have Richard or
Yeah.
Gordon address that one. I see that Gordon is on the
Washboarding is typically a drainage problem. It's not it's just when you drive perpetually over roads under wet conditions, you basically create a washboarding situation. So it's really a drainage problem. It's not I don't know how else to put it. I mean, you need to do something to make sure that the road drains properly. Otherwise, potholes are the same deal. I mean, going and filling potholes with gravel every year, it doesn't solve the problem. The problem is a drainage problem, and maybe Mark wants to talk to us a little bit in his presentation, but washboarding, potholes, they're all related to inadequate drainage.
Okay. And then have you seen any problems with outsloped roads and slope erosion?
What I suggest is that you attend the El Dorado workshop field day, because you'll see some real interesting consequences of improperly designed rolling dips. Outsloping sometimes can cause problems, but it's more likely it's rolling dips that are improperly located that cause downslope erosion.
Right. So anytime you concentrate water, you have the ability to increase its power to erode a slope. Ideally, outsloping is not concentrating water. So you have the slope of the road and it's shedding water the entire way. And so you're not concentrating anything. And ideally, you're not allowing any erosion. But if you are concentrating it because it's poorly implemented, as Richard said, then you could have issues.
That's a really good way to put it. I mean, outslope roads don't have points of concentration.
With rolling dips, have you seen erosion on the outslope?
Absolutely. So come to our workshop field day on July 19th and you'll see plenty of that. Right, Mark?
So folks may not know
Yes.
about the field day just yet, but we're going to give more information on that at the end. But I know this participant is quite far away from El Dorado. So what would you say about rolling dips and erosion on the outslope?
Well, rolling dips that, they concentrate flow, right? I mean, they're like directing flow to certain locations. And I've seen situations where they direct flow to situations of erodible soils. And so you get gullying below rolling dips. So it's a question of the spacing of the dips and the location of the dips and properly locating the dips so that they're not in areas that are susceptible to erosion. I mean, that's what it kind of boils down to. It's not rocket science, but just sort of saying we're going to put a rolling dip X number of feet along this road without considering what the conditions are below the rolling dip in terms of the erodibility of the soils. That you just have to take that into consideration. They're like culverts. I mean, they're just not made out of, they're not made out of metal.
If you have an insloped road with culverts at regular intervals, would the most valuable ditch armoring be in the last 50 feet or 100 feet before each culvert where water volumes are the highest?
I'll punt that to you, Susie.
Well, and I've even seen these culverts of David's, but I can't remember them especially and really think that through. So I'm not exactly sure where the water is the most. Where would the ditch armoring be the most useful? Before or after the culvert? Is that basically what you're asking, David?
Well, I mean, the objective is actually to disconnect the ditch from the water course. It's not a matter of armoring, it's a matter of disconnecting the ditch from the water course. And there's a variety of ways to do that. But that's the ultimate goal is to not allow the conveyor belt to convey sediment into the water course, directly into the water course. Is that what we're getting at here?
Yeah, I think so. I might just repeat the truism, which is it's not erosion that we're worried about as much as sedimentation, right?
Exactly.
So it could erode off of a slope, but if it doesn't go anywhere, then it's not going to get in your stream. It could eventually challenge your road or your cut slope or your fill slope, I'm sorry. But if you're most worried about water quality, which in a lot of locations, that is what we're worried about, especially on the coast with endangered fish species. We know that forestry activities can have some impacts, but if you look over time at the biggest impacts, it's actually the roads. So Yeah, it depends on I guess I'm going to say it depends, which is the easy answer. It depends on the resource that you're trying to protect, right? So if you're trying to keep the sediment out of the stream, your armoring or whatever activity you're doing is going to try and disconnect this ditch from the stream. But if it's a matter of keeping the sediment on the slope because otherwise you endanger the road surface, I guess I would advocate for putting the armoring where that's protecting it. So
Okay,
you're
so
not
there's
armoring as a cultural practice, but as a specific remedy.
yeah, there's two different issues here. One is delivering sediment to the stream, and the other is protecting the ditch from erosion. And so that picture I showed you of a armored ditch, they weren't trying to protect the stream from sediment delivery. They were trying to protect the ditch from incising, because incising of the ditch creates maintenance problems of its own. So you armor a ditch because you want to prevent it from incising. You disconnect the ditch from the stream because you want to protect the stream from sediment delivery. So there's two different objectives there, really. And Mark, you want to weigh in on this a little bit?
We're gonna go ahead and turn things over to Mark now too. I recognize there's more questions in the chat and we'll get back to that, but I think Mark actually might be addressing some of the questions as
Yeah,
well.
I
So
think so too.
Mark, why don't you introduce yourself and then you can get started.
Well, hello. My name is Mark Egbert. I am the district manager for the El Dorado and the Georgetown Divide Resource Conservation Districts. And I'm going to be transitioning my presentation into presenting in teams. Let me know when you can you see my screen by chance?
We can, but it's not in presenter mode yet. There you go.
Okay, well, just real quick, with that question about the the one that we were just talking about, I always think about the resource that we want to protect is our road, right? If we protect the road, we'll have associated protection for other resources like the streams and so forth. And the road is generally most of the time made out of soil, and so you want to protect your soil. Anytime you have exposed soil, you have an increased potential of erosion. Anytime you have an increase of slope, you have an increased potential for erosion. So slope and exposure are all sort of parts of the equation that leads to increased soil transport and eventual deposition somewhere, right? And every road, I've never seen a road that is the same. Every road is different. There's some similarities for sure, but it's really interesting because there's more than one fix or more than one design that's gone into these things, and you just really have to spend some time learning about it, monitoring it, and changing it. Sometimes you, like Richard said, you inherit a road, but I don't think anybody in here wants to spend millions or hundreds of thousands of dollars repairing a road and or fixing a road. And so the design and maintenance of it is really, really, really important because it really affects the pocketbook really quick. One of the measures, you mentioned armoring for that roadside ditch. I think, vegetation is one of the best ways of protecting soil. Rooting into the soil is always best. But if you can't, then looking at some sort of other practice. And we'll get into that here in just a minute. So I wanted to differentiate the presentation from Sue and Richard in the context of what, if I'm with a landowner, what's going through their head? I deal with it all the time on my property. We have a road and a trail system that I'm always trying to repair or fix or adapt to changes that I had no idea that were even going to be coming my way, and that were going to be impacting the trail or the road in a way that I could never have predicted, really, because maybe we got a torrential downpour that was much larger than the 100-year 2-hour storm event. So there's things that are unpredictable. But one of the things, so I'm going to try to put this in the perspective of a landowner and what they could think about throughout the year, and when to use help, what do you do when you're not getting the help. And I think Susie did a great job talking about that, but I'm just going to elaborate on it a little bit. So scheduling. you always find erosion problems during the wet winter season, right? It's never really eroding during the summer. But you always see the like that washboarding and things like that during the summer. Well, that's a wet winter season problem of not only drainage, but also I think it has to do with speed control over the road surface, people driving too fast, things like that. So pay attention during the winter, even when your road and drainage systems are functioning well. Sometimes little things become big things. And that's the biggest problem with roads that I see, is that small problems, when not rectified, becomes big problems. And cheap problems become expensive problems. And it's like, if you own a rental or something like that, always fix it, because it becomes a bigger problem and it gets more expensive, and the renters are not happy. And I also want to just say that, you want to establish a road system that minimizes the damage associated with the use of the road, but also when the road is not in use. And that's really when most of the damage occurs, whenever you're not using it, because, these are mostly seasonal roads, and where you're only using them whenever it's safe. The other thing is, again, try to preserve as much existing vegetation either adjacent to the road or within what I'll call the hydraulic connectivity of your whole road system, of where your outlets are, of where you're trying to control the water and so forth. I think vegetation is one of the most important, practical and self-maintaining sort of BMPs, best management practices, that you can use. One of the things I also like to look at is the hydraulic connectivity. And both Richard and Susie kind of talked about this, but you're never going to control the water on a large scale watershed. And it's even really hard to control water on a small scale watershed. And so you want to work with it. You want to work within your landscape, your environment, not only the vegetation and everything, but the topographical features and the nature of how water is actually functioning and flowing throughout the watershed. So understanding the flow paths, understanding where water is coming from. Sometimes there's springs, sometimes there's, all kinds of different ways that water is going to be moving throughout the watershed. You want to learn about that and then understand how your road interfaces with that watershed, so it's hydraulically connected. It'll reduce the engineering requirements and long-term maintenance costs of your road. And this is just to reiterate that, on a large scale watershed, there's, rivers, streams, other things, but then looking at a small scale watershed, a culvert or a rolling dip or anything like that, all have to be considered, because again, anytime there's a diversion point of any type of natural flow path of water, you're going to have to manage that water now, and it is going to be more costly and more impacting to the system. This is a little bit, I think, whenever it is hard to design a road on top of a ridge line and so forth, because you can't, water's going to go left or right or wherever it's going to go. But the most important thing is to get the water off of the road. You don't want water flowing down the road. That causes all kinds of problems. And it leads to, again, if you lose soil from your road surface, what is your road made out of? It's made out of the stuff that you're losing. So it's going to become much more problematic to fix that if you're losing the tread or the material from which your road is constructed. And so this is a way that there's a variety of different like winged ditches and other things like that to get the energy off of the road, get the water off the road, and get it into the natural flow paths of the watershed. And so erosion. There's a lot of different types of erosion out there. And, I think for the most part, one of the things that we would do if we came out to your property and we looked at, the road system, is we'd look at where's the water coming from? Is it surface erosion that's happening? Is it fluvial erosion? Are you having mass wasting where, fill slopes are giving way? And all kinds of different there's all kinds of different ways that soil can erode. And so you have to have a comprehensive, holistic approach to it. Whereas, it might not be just the ditch that's eroding. It might be also some erosion that's coming along the road is surface erosion as well. So just wanted to point this out, that there are all kinds of different types of erosion. And a lot of times, like, you'll see it raining and everything, and you'll see these pedestals on the soil. you know, and you will look out there and you would never even tell that has been sheet erosion or any type of erosion, but there's been such a loss of soil that the elevation of the profile of the road has been gone because you've had, you know, puffy soil, right? Because it's been eroding and you have that washboarding and puffy soil. Well, all of a sudden you're starting to lose that. If it rains, it's going to go off like crazy. But so erosion can happen fast, and there's a lot of different ways. So there's 5 sort of general conditions that I talk about, or situations that contribute to erosion along the road and so forth. And I was just wondering, you know, I talked about, you know, I'm not going to really talk about too many BMPs like Susie and Richard did, but I'm not sure if everybody knows how expensive a culvert is nowadays. I just put 3 culverts in my road, and they're 3 36-inch culverts that are over 20 feet long. And each one of them, just the materials was like $1,500. Then installing them was very expensive. So I think that if we look at the economics of things, we definitely want to invest in preventative and maintenance actions. So one of the things that I wanted to is just talk about the 5 general conditions or situations that are major factors as you evaluate your road, or evaluate when you need help and when you need to call someone to come out and evaluate these. These are maybe some of the questions or areas that you want to talk to them about. One is intersections, and Richard talked about this really well, you know, and how they compound hydrological effects of erosion or hydrologic energy going through the system. So general recommendations, but this is not, you know, because I haven't been to your road or wouldn't do it, but generally, water breaks, you know, or abandoning unnecessary bypasses or intersections where feasible. I would say abandoning is really, really good. A lot of times I see unnecessary roads or 2 roads that go to the same place. And a lot of times we could abandon one and revegetate it. And in a year, the landowner really is happy to not have to maintain 2 roads. Another issue that I wanted to also bring up that triggered my memory here is, does anybody have any issues with trespassing? You know, is anyone using your road besides you? And how are you controlling that? I know a lot of people out in the country are like, you know, I just have to keep people off my road. They're destroying my road. So like fencing is a best management practice as well, to prevent undesirable use beyond what the road was designed, or, you know, basically keep people off the property. The second one is sections of the road that intercept natural drainage pathways. So erosion of the road surface occurs when the natural drainage is intercepted or diverted by the road. So natural drainage pathways range from swells that may carry seasonal snowmelt to watercourses that flow for extended period of time. So again, you want to make sure that the natural drainage pathways are as stable and as functional to the watershed as possible. When you have to interact with a natural drainage pathway, you want to be able to do it so that the water flow is the primary functionality of that area, and the road is secondary, but we do want to pass through safely without contributing to any degradation of the channel or soil. Real segments of the road. So this is where all of a sudden you're like, oh, I've got a problem. This is where there's energy and there's water flowing along your road, right? So we want to get the water off the road. I don't know how many times that we see that there's where the left tire goes, that's where the water is going to, and they can't just get the water off the road. And there's so many easy different ways that you can do that. But it is, I think, one of the biggest problems that I see with roads that are degrading is that people are just not getting the water off the road. And I'll say one of the recommendations would be, you know, and all these water breaks, you know, water bars, all those things, but also hardening. This is where it starts coming into hardening. And Susie went over a lot of different ways that you can armor or harden the road surface. And that's where I go into this 4th section, is where you have topographical changes of the road, where you have steep sections. You know, a flat road, I think, is like most of the pictures we saw, like really nice, flat, windy roads. But you know, we live in the foothills. There's a lot of climbing sections, and this is where it starts getting really complicated, because again, increased slope correlates directly to increased erosion loss potential. So look at climbing sections, as well as approaches to stream crossing or waterway crossings, where the slope kind of gets a little bit steeper. Changes of slope are also areas where you want to pay attention. So again, the degree of erosion increases with the grade of the slope. So, and again, installing water breaks at more intermittent periods and adding armoring to the surface. And again, this is somewhat, again, where roads cross sort of areas that get flooded every once in a while. It could be low spots where water sits, like, you know, we talked about wetlands or different wet areas like that. It's really tough when designing a road and you're going through a wet, boggy area, and, you know, where the moisture under these clay soils is just going to give away, and you're going to start smearing or spreading that soil out. And it's like, you know, causes a lot of problems. And then you've got this, you know, puddle or massive water body in the middle of your road. So think about that, and either consider relocating to where it's a more stable subsurface, elevate it with armoring or rock. We use fords and other types of things like that. Corduroys was what we call them. We had a lot of these issues like this when we were working with the county and the Rubicon Trail Foundation to develop the best management practices toolbox for the Rubicon Trail. They had a cleanup and abatement order and actually had the road shut down, the trail shut down for an extended period of time. And we wrote the best management practices toolbox, and we had volunteers go out there and put the BMPs in along the Rubicon Trail. And then much of that happened in these areas where they had saturated low areas that were filled with water. And they did a good job, and they got the cleanup and abatement order waived. So we have two offices where I'm located in Forney Road in Placerville. We have the Natural Resources Conservation Service, which is our federal partner. They do have grants. There's a question in the chat about grants for funding. The NRCS does have the Farm Bill through the Environmental Quality Incentive Program that does provide cost share for road improvements if it's an agriculturally productive property, and forestry is eligible for that. And then the RCD, we have foresters, and we also have engineers from the NRCS that we can come out to your property and just assess, evaluate, and develop a plan for the property and the road. There's never a charge or anything like that. We can also facilitate any type of application to the NRCS EQIP program as well. So with that, end of presentation.
Great, thanks, Mark. Well, we'll take a couple more questions. We have some time. I don't believe it was addressed either, but can any of you speak about single post trash racks?
I've seen them. I really can't say how effective they are. I mean, sometimes they're effective and sometimes they're not. I don't really have anything to say. Do you have anything to say on that, Mark?
Yeah, I think, you know, a lot of us have gone through wildfire lately, and there's a lot of debris that's been flowing down these stream channels, and, you know, the rate at which we see these peak flows happening, and it's carrying a lot of debris down to these culverts, and they're getting plugged all the time. And so we do have specifications and design standards to design a trash rack for the inlet of a culvert, to keep those trying to keep those clean as possible. But there's a lot of material coming down these streams. But yeah, it's a really good question, and something that we used to use a lot more than we do today. I think historically these culverts have been undersized, and I think people are kind of just getting it to where they're oversizing their culverts now. But there still is that debris flow problem.
Hey, Mark.
I was just going to describe what it is for people in case they didn't.
Yeah, go ahead.
Yeah, so the idea is, right, that a culvert has to pass water, sediment, and debris, and sometimes you get big logs coming down as the stream bank collapses, right? So a trash rack is a barrier, and traditionally they were kind of an actual fence, you know, but those can like plug up with a lot of stuff. And so a single post, I've seen Caltrans is the one who seems to do this the most, is just a post that a tree intersects and then is supposed to turn the tree perpendicular to it, and then it can go through the culvert. So that's the whole concept of the individual post trash rack. Sorry, go ahead.
No, I was just going to say, Mark, do you, some of the people that were on this might want to go to our workshop, field day on the 19th. Do you want to talk a little bit about what we're going to show people on that?
Yeah. We're going to look at it is a county non-maintained road. It is a dirt road. It is, it's highly used both by Forest Service personnel because it goes to the backside of the Placerville, of an orchard up there for the Forest Service. And then it goes into Forest Service lands. It's on the backside of Ghost Mountain Resort. It's steep, it's windy. It has a lot. We just did a fuels project on there, and we just put some BMPs on there with a contractor. And I'll be able to show you what you can do with a certain amount of money. And money with limiting funds, what can you do and what do you not do, and where do you concentrate your efforts? So that's what we're going to look at. We're going to look at a variety of different ways to stabilize the road and get water and address drainage within the confines of budgets.
Thanks, Mark. And I'm going to share more information about the field day at the end here. I want to get to some more of these questions. Can wood chip be used for surfacing roads?
I don't like them. I think they they're light, they float, they get in the way, they don't do a good job to compact the travel surface, and they're just not designed for that type of use.
I would say I definitely see it, especially here in the Tahoe Basin, as an erosion control measure on a road, but it's not usually a road that gets much use, right? And it certainly shouldn't be something that you would build into a road with an additional items on top, right? Because then it's going to decay and lead to a compaction issue with your road. It seems like a convenient thing to do with chip if you're chipping a bunch of stuff is to put it on the road. But I see those as very temporary roads when they're doing them and not something that you would be using very commonly. But, Mark's right. It can float right away, that little chip stuff. So it has limited effectiveness if it's a very steep road. If it's a flattish road, it might work for that purpose for a while.
And thinking about road repair, what a participant has a road where a tree tipped over on the outslope of the road and took out a section of the surface of the road. What would be the best steps for managing that damage?
Which one do you want me to go?
Sure.
So just think about, you just took out a significant structural component of your road, and the structural integrity is not going to be restored until you restore the what was removed, right? And so you're going to have to import material to fill that gap, and you're going to have to compact it. I know that disposing of the tree is something, and again, it's hard to say how long that fill slope is and all that kind of stuff. But it's the structural integrity of the road that you want to maintain.
So it looks like one participant, in addition to having wood chips being seen as for surfacing, they've seen the hard part of walnuts and almond shells also used for flat parking areas. So where can folks find information on the type and size of gravel to use to armor roads?
Well, I'm thinking it's that handbook for ranch roads that we have on our website. I think it's recently been updated. It's much more exhaustive with that kind of design information. But that would be a place to start. Gordon Keller was on our call and took off. He's just designed another low volume roads manual. He's done work all over the world on that kind of thing. So there's more description of gravel sizes and applications in those two handbooks. That's where I would go. And for David's question, I see he's asked, is it possible to take an existing insloped road and reslope to outslope for some segments? And can a road work when it alternates? And I would say, yes, that's totally common to see that done. So it doesn't have to be one style of road in every area. Maybe there's parts of your property where outslope wouldn't work and you need to stick with your ditches. But yeah, it doesn't have to be all one or another. Those things can work together.
Do ditches require a different rock type or size than what would be on the road? Mark's nodding yes.
Yeah, you know, usually ditch is more angular because you're trying to dissipate the energy. Whereas on a road surface, you're trying to obtain, you know, some level of compaction so that you're traveling on a stable road surface where, you know, you're not necessarily looking at that same level of compaction where you're just going to shoot that water down that ditch, you know, and so you want to dissipate the energy in the ditch. That's the difference.
Mm-hmm. Here's a little more of a road design question. How would a landowner balance the requirements from CAL FIRE regarding road widths for safety with remote properties?
Can I answer that?
Go right ahead, Richard.
Yeah, there's no balancing. The whole issue is emergency access. So if you, for example, live in an area where fire is an issue and the road standards are set in part to address the fire issue, you have to comply with those issues. I mean, you have to comply with those standards. You know, I don't think there's any, you know, sort of, I don't know, maybe Mark, you want to talk to this a little bit?
I would always consult with your local fire department and get them to provide input on accessibility issues and the whole works. But obviously, the wider or the more turnouts that you have, the better. We just wrote a forest management plan for a property that is down this very, very steep, long, one car width road, and they want to put, you know, fuel breaks in there and all this other kind of stuff. And the fire department's like, we're not driving down there no matter what. That's ridiculous. And so there's some limitations there. So consult with your fire department. Yes, they're going to be pretty aggressive because they're firemen, but they're great resources too.
Well, and you know, on rural subdivisions, CAL FIRE is typically a responsible agency on anything that requires CEQA analysis. And in those cases, they will tell you what their requirements are, you know, for emergency access.
I was just going to bring up, this might be the perfect reason to collaborate with your neighbors. Although if you're really out there, maybe you're out there without neighbors, but there are road associations, which are always problematic to get people to agree who just happen to live on the same road. But if it's really remote and there's this access issue, it's something the entire road denizens group would have this issue. So if you can get collaboration to work on the roads. And I was also going to point out the fuels reduction applications too. There do seem to be plenty of opportunities to work together on fuels reduction along roads. So maybe the goodwill that you develop there or some of the funding sources that you develop could help you try and address some of the road limitations. Although Mark doesn't sound terribly optimistic about that from his description.
No, there's always a will. There's a will, there's a way. And again, if it benefits you, it's most likely going to benefit someone else too. So I just invest in the discussion and the planning, and bring your NRCS or your UC Cooperative Extension or RCD folks out there with the fire department as well, because again, they're there to help you. So
Great. Thanks, Mark. I'm going to go ahead and stop the recording for